All right. So 1.5b, the assignment was, where's my pen? 1.5b. It was 35 to 38, 35 to 38, 35 to 38 all. And then it was numbers 65 to 71, 65 to 71 odd on page 59. So what questions do we have? Should I just do one from each section? Or what specific problems, any specific problems that people have that they'd like me to cover for this assignment? Any specific question? 38. Okay, I can do 38. And 37, maybe. 37, 38. Other specific questions? Where'd it go? 65, yes, I see. 38. 38. A lot of people have questions about 38. Okay, I can do 38. And then, what about the next section? 65, 71, maybe 71? Try 71. All right, let's try 38. Let's 37, forget 37. 38. Easy enough. So we have function composition was f of g of x, which means what you're doing, you have two functions, and you're putting one function sort of like inside the other, like a little surprise, like a Kinder egg. One is inside the other, and you can also, that's f of g. If you have like an outside function, then you have an inside function. F of g, f is the outside, g is the inside. Or you can have g of f of x, which is g is the outside and f is the inside function. So these two sort of ways we can see the composition of functions. So in 38 we have f of x. F of x was 38, x cubed, and g of x was 1 over x. And it wants us to find f of g, g of f, and f of g of 0. A, B, C. So it wants us to find f of g of x. So this just means when you have a function like this, remember, we read it backwards. You take the x, you plug the x into g, so that means it's a variable, and then you take that g and you plug it into f. Like a little dolphin. Back, right? Jumping back. So I'm going to take the outside function as f. So my outside function is the something cubed. Right? Outside function is cubed. My outside function. Inside function is g, so I'm going to take this 1 over x. Here's my g, 1 over x. I'm going to put it inside the x part, inside the x part. So that means that inside I have 1 over x cubed. And that's the equation. Done. F of g is 1 over x on the inside, the g function on the inside, and the cubed function on the outside. Okay? Easy. What about g of f of x? Same thing. Outside function is g, so I have my 1 over something. So you see, when I do my outside function, I write it and then leave a blank where the variable was. Every variable becomes a blank, and that variable gets filled in, this time, with the whole g function gets into the x. So it's going to be 1 over blank. That blank is going to be my f. That's going to be x cubed, like this. And that's my answer. That's my answer. 1 over x cubed. So they're a little different, right? Really, they're the same if you simplify, but this is how you do it. You do the outside function, you leave a blank, and then you do the inside function, put that inside the x. Now C asks for f of g of 0. F of g of 0. And we already know what f of g is. We did that up here. F of g is 1 over x to the third power. So I'm going to use this function, 1 over x to the third power, and I'm going to plug in a 0 for my x. Plug in 0. So it becomes 1 over 0 cubed, which is 1 over 0. And what's my answer going to be for that? What's 1 divided by 0? Am I allowed to do that? Correct, Jessica. Correct, Destiny. Correct, Christopher. Undefined. Undefined. Not allowed, so my answer for that one is undefined. Oh, does it say part D also? Is there a D? No, just part C. Yeah. All right. So f of g of 0, right? You plug in the 0 into the f function. Figure that out. Questions about 38? Right, your composition of functions, you put one function inside the other, right? You have an outside function, write your outside function, write your inside function. Outside function, leave a parenthesis, and then put the inside function into that parenthesis. Let's try 71. 71. 71, so these sections I have an equation, and I want you to, I give you the combination. So h of x, it says, was x plus 3 to the, oh wait, no, x plus 4. Look at the wrong one. X plus 4 to the second power plus 2 times x plus 4. Like that. So these, we need to figure out what is f and what is g. If h is the combination, we need to find the inside and the outside function. We need to find the inside and find the outside function. And you look for these clues, these parentheses. Well, you see, inside kind of has this x plus 4 happening here and here. So I can call this x plus 4, maybe that's inside. And if you imagine, use your imagination, powerful, powerful imaginations, use those and think like, well, this x plus 4, it could be this whole thing is like x. This whole x plus 4 thing is like x, like my holder, like my placeholder. So if my inside function is g of x plus 4, right? That means my outside function for f, that place where g was, is my x squared plus 2 times this x piece. Like the whole thing, that whole x plus 4 is like an x, right? Like x. Imagine quotes around it, right? And this would be how we find our inside function and outside function, f and g. So you're recognizing where the composition happens, right? Seeing what function is getting plugged into another. So on your quiz, you will be asked to do some composition of functions. And maybe you'll be asked to break apart a composition that's already been done. Find the f and g. Which functions, name the functions that make it. So make sure you know composition, how to find them, how to plug into compositions of functions, f of g of 0. Plug those in. Get this all figured out. All right, so get this assignment into me again. If you turn in all the assignments of 1.5 together, they'll all be considered on time. Get that to me by the end of the day today. Let's move on to the new stuff. New page. Let's look at 1.6. So notes 1.6, function inverses. Last stuff. Function inverses. What is an inverse of a function? Inverse of a function. An inverse of a function is when you have, let's see, how do I describe? Functions have an inverse when you swap the input and output of a function. So what I mean is, let's say you have f of x, right? And you have these various, the domain, right? The domain, also called the inputs, right? Like 1, 2, 3. And you have your outputs, your range, output, 4, 5, 6. 4, 5, 6. So let me erase this. Let me put this f is the spot. F of x, let me do this in red. No, f of x will take all the stuff from the inputs and map them to the outputs. So like 1 goes to 4, 2 goes to 5, 3 goes to 6. Right? A function takes an input and gives you an output. So your domains are all the x's, and your range is all the y's. Whoa. All the x's and all the y's. So a function maps an x to a y, right? Goes from x to y. An inverse goes the other way. It takes the connection that you have, and we say f minus 1. This is the inverse. We say f inverse. F inverse. F to the power of negative 1. You see the little negative 1 there. This means that f is the inverse function. And it reverses all the connections. So we go from the range, it goes to the domain. All the y's give us x's. So the 4 maps to a 1. The 5 maps to a 2. So the outputs become the input, and the inputs become the output. They swap places. Swap. No, let me say it a little differently. The output becomes the input, and the input becomes output. So all the x's, all the y's, I should say, all the y's, all the outputs. No, don't worry about that. Outputs become inputs, and inputs become outputs. So they swap places. So what you're doing is you're really switching x and y. An inverse swaps x and y. X and y. They change x and y, they swap their order. So for example, if you had a function f of x, and let's say you had a table, x, y. Say you had a table here, you had like 2, comma, -1, 0, comma, 3, and 6, comma, 9. So you had a table like that. For the inverse, f inverse of x, we'd have our x, y table. And we would literally just switch them around. -1 becomes x, and 2 becomes y. 3 becomes x, and 0 becomes y. 9 becomes x, and 6 becomes y. Literally, you just change them around, flip them around. And that's an inverse function. I'm going to keep moving, but if you have a question, if you can't see something, you want to know what something is, yell at me in the chat, or unmute yourself and tell me. So you need me to stop on something for a little bit. So x and y switch places. And that's how you make an inverse function. So that's great for tables, for points, you can just switch them, right? But how do we switch equations? An example, switching equations. Finding an inverse equation. So let's say we have f of x equals to 2x minus 4. I want to know, what is f inverse? What's the equation? How do we find this equation for f inverse? Every function usually has an inverse. Okay. Every equation has an inverse. So the way we do it is real easy. Real easy. I said that you swap x and y, right? So you can imagine this f of x function is like y equals 2x minus 4, right? In the inverse, you're literally going to just change x and y. So it becomes x equals 2y minus 4. Swap x and y. And then to find the equation, you solve for y. Get your y by itself. Get the y by itself, and that'll become your inverse equation. So, to solve, I've got to add 4 to both sides, plus 4. So I've got 2y equals x plus 4. Divide by 2. Divide the whole thing by 2. I've got y equals x plus 4 over 2. And this is my f inverse equation. F negative 1 is x plus 4 over 2. Whoopsie daisy. Running out of room here. Negative 1 of x equals. So once you got the y by itself, right, you swap the x and y, solve for y, and you get your inverse equation. Pretty easy. You mean the 4 divided by 2? Well, no, because this is x plus 4 together, right? Like, you can't say x plus, if I said x plus 4 over 2, and I made it equal to x over 2 plus 2, this is not the same. Right? If I plug a number into x, let's say I plug a 6 in here. Well, this would be 6 plus 4, that would be 10 over 2, that would be 5. If I plug a 6 in this one. If I plug a 6 here, 6 over 2 is 3. 3 plus 2, I guess that is 5. Never mind. Bad example. I mean, I guess you can equal each other. You could do this. I would just leave it, though, as a fraction. I mean, what you can't do is just make it like x plus 2. This would be wrong. X plus 2, that would be wrong. You don't just do the 2 and the 4. You'd have to do both the x and the y, x and the 4. Easier to just leave it like a fraction. Don't even worry about it. Don't even worry about it. Yeah, leave it like a fraction. You can't just simplify the x with the 2 and the 4, because that x is also on top. So it becomes, right, too complicated. Well, too dangerous, I guess. X plus 4 over 2. Other examples. Let's do another example. What if I had an equation? What if I had an equation like f of x equals x squared plus 7. X squared plus 7. Okay. What is f inverse? So to find this, I again swap my x and y, make this into a y equals x squared plus 7. You know, I'm going to make it cubed. Well, I'll leave it squared, actually. That's okay. X squared plus 7. And then swap my x and y, make it x equals y squared plus 7, and get the y by itself. So here's my equation. Y equals x squared plus 7. I want to get the y by itself. Swap my x and y. Now I need to do some solving. This is just algebra. Stuff you've seen before. Minus a 7 on both sides. Minus a 7 on both sides. So I rearrange. I get y squared equals x minus 7. Then how do I get rid of this squared on the y? How do I get rid of my squared? I have to square root both sides. Square root both sides. And that square root cancels the 2. Y equals square root x minus 7. And so that's my inverse. F negative 1 equals square root x minus 7. Okay. When you have a squared, remember you cancel with a square root. If I had a y to the 3rd power equals x minus 7, and I did a radical, I would do the cube root of both sides. Cube root of both sides. Whatever the exponent is, to cancel an exponent, you do a radical with the same, called an index. You do the same radical. They cancel out, and you have y equals the cube root of x minus 7, right? The 3 is kind of inside the little radical sign. Right? In a square root, really, there's an invisible 2 here. We don't write it most of the time, but square roots have like an invisible 2 that goes in there. We don't write it because it's like the default. It's like the default. Square root is obviously, it's like automatically 2. If it's something different, if it's a cube root, or a 4th root, or a 5th root, you can have any kind of root you want. You can have any kind of root you want. So if it was a cube, we would do a cube root. If it was a 4th power, we do a 4th root. You can have any kind of root you want. And they always cancel the exponents. Cancel these exponents. Really what a radical is, it's a fraction exponent. But anyway, we'll get to that later. Did you all know that? The square root of x is really x to the power of 1/2. Did you all know that? That's what a square root means. If I had a cube root of x, that's x to the 1/3 power. Oh, is that what square roots mean? Interesting. So sometimes I could write this answer like x minus 7 to the power of 1/2. That's also fine. Weird. Weird. Why is math so weird? No, not weird. It makes perfect sense. Think about it. It'll make sense to you. Anyway, inverses, okay? Inverses, square roots, radicals, all this stuff. Make sure you know how to do all that. Let me show you one more thing. How do we check? Sometimes I'm going to give you 2 equations. I'm going to ask you, are they inverses? Are these 2 functions inverses of each other? How do you know? How do you check inverses? To check inverses, to check if 2 functions are an inverse, you use Fogg and Goff. You use f of g of x and g of f of x. You plug the equations into each other. And what will happen is plug equations into each other. If they cancel and leave only x, then they are inverses. If, when you plug them in, everything will cancel out and leave only x behind, then you know those two functions are inverses. If they cancel out. And you need to check both. Must check both ways. With g of f of g and g of f. You have to check both of them. Both ways. So let's do an let's do an example. Say I have the function like, are these inverses? Say I have the function f of x is 2x cubed minus 1, 2x cubed minus 1, and I have g of x, which is the cube root of x plus 1 over 2. Are these two functions inverses of each other? How do we tell? Well, we're going to do f of g and check it out, and then we're going to do g of f and check it out. So we have to test f of g of x. Test f of g. F is my outside function, so I'm going to write the f function first, and the x part I'm going to leave that like I'm going to use my f function, my outside function first. F is outside. So I'm going to write this function out, but I'm going to leave the x part. I'm going to leave a parenthesis there, a blank, because I need to put g. I need to put this whole thing into the little x in my f. Right, that's what it means. Inside function, right? There's the inside part is the x. This whole thing goes inside that x. So I'm going to leave a 2, big parenthesis, cubed, minus 1. And in the parenthesis, I'm going to put my g, which is the cube root of x plus 1 over 2. I put the whole thing, the whole g, inside my x. My outside function, my f, inside function, my g. And now I have to simplify. Now I've got to, like, cancel things. See what can cancel, see what they can become. So how do I begin? Well, look at start at the inside, right? You got this cube root, the cube. Well, this is very nice, right? You see this cube root that I have. The whole thing is a cube root, and that whole cube root is being cubed. And like I said, when you have a cube root and a cube, those two things cancel out. My cube root cancels my cube power. So they'll be gone. Very helpful. Let's see what that does. 2 times x plus 1 over 2 minus 1. So my cubes canceled. What else can cancel? Well, let's see. I've got my 2 times this equation here. Well, I have a 2 down here on the bottom. Well, oh, interesting. This 2. This 2 is like a fraction. I can imagine this 2 being 2 over 1. And if I multiply 2 over 1 times something over 2, these 2's, those 2's also cancel. Because it's a multiplication and a division. Figuring out how to cancel these fractions. The 2 on the top cancels with the 2 on the bottom. And it always works out like that, right? When you have parentheses or when you're multiplying. And so you have, this is x plus 1 minus 1. Ooh. x plus 1 minus 1. And yeah, look at that. Also, my plus 1 minus 1, well, those cancel too. So I am left with just x, and so that checks out as an inverse. Because that was what we require. We require everything to cancel, and we're left with only x by itself. That's how we know it's an inverse. Yeah. All right, we tested the f of g. We got to go the other way too. Because maybe it works one way, but not the other. We got to do it both ways. So now we're going to test. Now, what am I doing here? Test g of f of x. So g of f. So again, now my g is the outside equation, so I'm going to put the whole thing here. And then into my little x, I'm going to put the whole f equation. So g is the outside function. Start with this, and then little x here is going to be my f. So I'm going to put a parenthesis there in my g. So my g function is, I've got the cube root of something, right? My parenthesis. What is it? Plus 1 over 2. Plus 1 over 2. And in that parenthesis, I'm going to put the g function, the f function, my f, which was 2x cubed minus 1. 2x cubed minus 1. And I want to see these things cancel out. So what can cancel? What am I going to cancel first, everybody? Type in the chat. What do you think? Let me take a poll. What should I cancel first? The threes? The radical? Yeah, I have a third power here, and I have a radical here. Seems like I can cancel those out, right? It seems like I can. All of you are wrong. I'm sorry. I can't cancel the radical. I can't. Why not? Why can't I did it before? Why can't I do it now? What's the difference? Well, look at over here. Here, right here, everything was inside the radical, and it was like exactly connected, right? It was like radical, square root. They were like butting into each other immediately. In this other situation, this radical, this cube root, I have this cube root happening to the 2, to the 1, to the other 1, to the 2 over here, and this is like inside. This x cubed is like hidden away, right? Yeah, it's inside the parentheses. It's not like they're not next to each other. They're not right next to each other. So I can't cancel them if they're not next to each other. So I got to do other stuff first. I got to cancel other stuff first. See if I can get rid of stuff. And a few of you said this, that -1. Yeah, the -1. A few of you said this. Yeah, because of the parentheses. So the thing that I got to cancel first, I don't need the parentheses here, right? Is there anything I do with the parentheses? Like, not really. So I can kind of like erase these parentheses, and then we can see that this 1 and the -1, these two things cancel out. I don't need these outside parentheses, right? These two things, like this parenthesis here, we're not really holding anything. It's like if I said 2 plus 3. Do the parentheses matter? Do the parentheses matter in this 2 plus 3? No, they don't do anything. It's 2 plus 3. Why even write the parentheses? Same thing in the situation here. We had a parenthesis here, but it wasn't doing anything. There wasn't a number. Like if there was a number in front, that would matter. Right? This would be important. But there's no number there. There's no real reason for these parentheses. So we cancel the 1 there. So, okay, that's a little bit better. Cube root of 2x cubed over 2. What am I going to cancel now, everybody? What should I cancel now? Next thing. Easy thing. It's my canceling piece here. Yeah, you're all right, the 2. This 2 divided by 2, I can cancel that. I want to get rid of that. So I want to get access to this cube, right? So now that becomes cube root of x cubed. Now they are next to each other. Now they're all alone. Mono a cube. Cubo a cube. And now that they're together, like next to each other, now I can cancel out the cube and the cube root. Because they're all alone. Equals x. And so that checks out too as an inverse. Okay. So you're testing these, you're plugging them in, see if they work. Should we do one more? Let's do one more. Uh-oh. Oh, I'm out of room, everybody. Too much writing. I'm going to do another page. I got to go to another page. Everyone got this? Can I go to the next page? I'm going to click the next page. All right. A couple more. Let's try. Let me see. What if I have, for example, something like f of x is x minus 2 over 5, and g of x is 5 over x plus 2. 5 over x plus 2. Could these be inverses? Looks like maybe, right? If we saw, right, things kind of flip around. There's a plus 2, minus 2. Maybe these two are inverses. Are these inverses? So we have to test. F of g of x. Test it out. So f is the outside. Let me do this parenthesis, right? That's my, whoops, I need a little bit bigger parenthesis. So I need to put the g, I need to put this whole g into this little x right there. So that's like whole thing here, minus 2 over 5. And this is going to be 5 over x plus 2. Oops, 5 over x. Okay. So now I gotta just canceling. Yeah, I can cancel my 2, right? So here again we have a situation where there are parentheses. These parentheses don't matter anymore. So this is very nice, right? Very nice. So I can cancel the 2 and the minus 2. That's useful. So I'm gonna get 5 over x over 5. All right, I've got a fraction over a fraction now. How do I solve this? What's the word we use? How do I fix this? Well, our bottom fraction, make it over 1. Whoa, 5 over 1. And then what do? What's that called? A little flip? Yeah, flip-a-do. A little flip-a-dee, flip-a-do, flip-a-da. flip it around and multiply. So let me see, this becomes 5, oopsies, becomes 5 over x times 1 over 5. And again, I have a 5 on the top of the fraction and a 5 on the bottom of the fraction, and they cancel out. So what am I left with? X? Am I done? Did I do it? Is that right? Do I have x left over? Seems like x is the only thing, right? What's my final answer? Is it x? Cancel the 5s. Edward, thank you. Yes, 1 over x, Destiny. Yes, exactly. The x is on the bottom of the fraction, people. Do not forget that. It's 1 over x. Yeah, that 1 on the top of the fraction is still important. This answer, when these cancel, is 1 over x. So are these inverses? Is this okay? It is not. Not inverses. And so I am done. I don't even need to test my other situation because I know I got something that doesn't work. If it doesn't work, it doesn't work. I don't need to test the other one. It's just it's not an inverse. It didn't work. It has to work for both. If it doesn't work for either one, we're done. Done. Okay. All right. So that's testing inverses. You know how to do that. Plug them in, see what you can get. Last thing, and this is just for your information. So we did equations, we did tables. In math, we have 3 different representations for these ideas: tables, functions, and graphs. So I'm going to show you what graphs of inverses look like. Graphs of inverses. Graphs of inverses. What do graphs of inverses look like? Inverse graphs they swap their x's and y's, right? So what this means is that they mirror or reflect over the line y equals x. Inverse graphs have like a kind of mirror, right? So if you have a graph, like let's say you have a graph of, it looks like, I don't know, like, it's called parabola, right? Parabola. Okay. Let's call this f of x. If you imagine a dotted line right here, this dotted line, and this is the line y equals x, you can imagine like folding this parabola here over the line and getting like another graph here, right? So they can match up the pieces, see where they go. And what that would look like is it would look something like this. This would be f inverse of x. Right, you can kind of imagine like draw a line between these two places, right? And all these lines going through this, like it all matches up, right? All this matches up here. This matches up with that, that matches up with that, that matches up with that, right? They all match up. like through the line, they kind of create this folded, reflected piece here. Reflected, reflect, reflect over y equals x. It creates this kind of matched graph. I'm not going to make you graph too many mirrors. Yeah, like a mirror, exactly. Oh, that word. Yeah, let me do that a little bit better. M-I-R-R-O-R. Mirror. Over the graph. So that's how we can do graphs of inverses. We can also, swap their x's and y's. So, for example, if I have f of x, if I give you like, let me move this a little bit more. If I give you like a function here, like 1, 2, 3, 4, 1, 2, 3, 4, 5. Let's go like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 up, down, left, right. If I make, let's say I have a function, let's say right here. And then let's do a line like here. And let's do another one like here. And then I've got one like here. So let's say I got my graph going something like this. That's f. There's my graph f of x. What does the inverse look like? So here's my line. Here's my line. Y equals x. Y equals x. What does my inverse look like? Well, to find out, I can look at every single point. In this location, this is -3, 0. And I just have to swap x and y. So I'm going to make my new point 0, -3. 0, -3 right here. 0, -3. And that's my new point. And we said swapping x and y. This one, -1, 3. This one is -1, 3. My new point, 1, 2, 3, -1 right there. 3, -1. This point I got 1, 2. 1, 2. My new point, 2, 1 right here. And this is 3, 5, 3, 5. 3, 5. My point, 1, 2, 3, 4, 5, 1, 2, 3, 5, 3. You match them up in the same order. Bam, 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 bam. Look at that. Let me try this a little bit better. Here, 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 here. There you go. Mirrored graphs. Here, 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 here. So swap your x and y points, and that'll get you your inverse coordinates. All right, everybody. Whew. That's a lot. Our test, I told you I'd let you know, quiz for Chapter 1 is going to be on Friday. It'll not be on Wednesday because we spent too much time here. We're going to spend Wednesday reviewing. We're going to spend Wednesday doing, and our quiz is going to be on Friday. But I do want you to do a homework assignment for me. Homework assignment for me for 1.6. Homework 1.6. So I'm going to write down this page number 69, and numbers are going to be 9 through 14 all. Test, f of g and g of f. 21 to 24 all. I just want you to match. Test, no graphs for this, no graph. It's going to be 59 to 67 odd. And 68, 79, and 80. Those questions, that's your homework. Due Wednesday. Wednesday. Okay. Practice your inverses. Practice these questions. Practice your composition, your graphs. There'll be a couple graphs. Oh, this is f inverse, by the way. F negative 1 of x. Check your situation out. Catch up on your homework this weekend. Catch up on all these assignments this weekend. That's it, everybody. Thank you. Yes, say goodbye in the chat. Once you say goodbye, you're free to go. Have a great lunch. Have a great weekend. If you want to stick around, I'll help you out. But that's it for me today. Good job, everybody.